We get Kyler, he's visiting the museum, he wants to take a guided tour. A friend suggested that he do the tour with DeMarcus rather than Cody because DeMarcus's tour was more informative. Tours with DeMarcus depart every 45 minutes, while tours with Cody depart every 30 minutes. What's the probability that Kyler is going to have to wait 20 minutes or less for each tour guide? So what we're going to do here is we're going to represent this on our own coordinate plane here. So what I'm going to do here is I'm going to put Cody on the x-axis, and we know Cody, he goes every 30 minutes, while DeMarcus, he goes every 45 minutes. So we're really going to do an area model here. So my sample space is going to be, 30 times 45. And 30 times 45 is 1350, isn't it? Now, according to our problem, I want to know what happens if he only have to wait 20 minutes. Well, that means 20 minutes for Cody, 20 minutes for DeMarcus. So in other words, my wait time is going to be 20 times 20, which is 400. I better write that down. 20 times 20, which is 400. So the probability that we'll have to wait less than 20 minutes is going to be 400 out of 1350. And 400 divided by 1350, that's about 30%, isn't it? That's the first question. Now the second question says, what happens that Kyler will have to wait 20 minutes or less for one of the tour guides? Okay, so in other words, we're just going to look at one of them. And we know for the first part, we've got 30%, don't we? But that's not really what they're asking. So now what we're going to do is we're going to look at each part here. And so the region bounded by the line x equals 30 and y equals 20 represents a possibility of waiting 20 minutes or less for Cody's tour. So I'm going to do this here. This is going to be 20 minutes or less for Cody's tour. So 20 times 30 would be 600, won't it? And then we're going to look at DeMarcus's tour. And that will be 20 by 45, won't it? So this part would be DeMarcus's tour. Let me color that in. So that would be 900. Now my total sample space is going to be 1350, isn't it? So we're going to go 1350 plus 1350. But now the only issue is, notice this section right here has been counted twice, hasn't it? So I'm doing like kind of an OR probability. So I better subtract off my 400 over 1350. So 600 plus 900 plus 400, or minus 400, would be 1100 out of 1350. 1100 divided by 1350, they have an 81% chance of waiting 20 minutes or less. I think that's it for, A permutation. A permutation is where the order doesn't matter, as long as, or I should say the order does matter. So doing track 5 and track 7 on a mixtape is different than listening to track 7 and track 5. That's what we're saying. So the way to do that, like if I have 7 tracks, I know for my first play, I have 7 choices. Then I've already taken one of them, so I have 6 choices, and 5, and so on. So 7 times 6 times 5 times 4 times 3 times 2 times 1, that's 5,040. Now you have a key on your calculator that does it. That's called the factorial key. So the factorial key, if I press my function key, let me clear that out. And let's say I want to do 7 factorial. What I do is I press my function key. It's in the lower right-hand corner. And notice we get that same answer. So that's 5,040. And what we would do. Notice 0 factorial by definition is 1. That's just what it is. 1 factorial will be 1. 2 factorial will be 1 times 2, which would be 2. And then 3 factorial will be 3 times 2 times 1, and so on.